Let's solve part B now. So now we have to differentiate this definite integral, right, with the limits from 1 to 2, of this entire expression. We have a division over here. So the method is again to substitute, right? We have to make it more concise. Now this is a bit more difficult to notice at first because it's a lot of terms, but let's start with something at least. Start with one step and then you see how closer you get. So for instance, when we look at this denominator, there is already something common because we have a common factor of 2 over here. So that's 2, 4, and 2. Now let's just work with the denominator to see where we get. So if we take 2 as a common factor, what are we left in the brackets? What we're going to have is x to the power of 6 plus, over here we're left with 2 times x to the power of 5, and from the last term we're left with x to the power of 4. Now, with that said, we can see already something even more common, because this green expression over here is the same as x to the power of 3 plus x to the power of 2 to the power of 2. Now let's see why that is the case. Let's open the brackets and we'll prove it. Well, x to the power of 3 plus x to the power of 2 to the power of 2 is going to be x to the power of 3 to the power of 2, which is x to the power of 6, plus 2 times every term, so 2 times x to the power of 3 times x to the power of 2, plus x to the power of 2 to the power of 2, well that's just x to the power of 4. Now we could write it as x to the power of 6 plus 2 times x to the power of 3 plus 2, which is x to the power of 5, plus x to the power of 4. What do we see? Well, that's just this green expression that we were talking about, meaning that we could write this entire denominator, as the following. Let me just zoom out to get some more space. So we could write this denominator over here below as 2 times x to the power of 3 plus x to the power of 2 to the power of 2. Now, with that said, we want to find the connection, a relationship between this term and whatever is left in the integral. And what's left in the integral is this expression over here, because we just took care of the denominator. Now, is there a relationship between this and that? Well, there is, because if we differentiate, let's try to differentiate this term. That's x to the power of 3 plus x to the power of 2 derivative. If we differentiate this term over here, what do we get? Well, if we differentiate x to the power of 3 plus x to the power of 2 with respect to x, we're left with 3x squared from the first term, so that's 3x squared, plus 2x from the second term. What do we notice? Well, this thing is the same as this term over here. So we already found a connection, meaning that if we're going to substitute like we just did, so u equals to x to the power of 3 plus x to the power of 2, we can get somewhere. So let's do that. We will have the following. We will have du divided by dx, right? That's just u derivative with respect to x, is equal to 3x squared plus 2x. And to write it in a better way, we will just say that du is equal to this thing multiplied by dx because of the cross multiplication. So we have 3x squared plus 2x multiplied with dx. Now with that said, we can see that we can substitute values into our integral. This thing, right, 3x squared plus 2x times dx is the upper part of our integral. So this green thing is going to be our du, and on the denominator, on the lower side, we have 2 times u to the power of 2. So this entire thing over here is just going to be 2 times u to the power of 2. So there we go. We just made the entire expression in terms of one new variable. And as we saw in the previous video, if we convert from the variable of x to the variable of u, we must also convert the boundaries, meaning that the new boundaries are going to be the following. If x is 1, the boundary in terms of u is going to be equal to, where was it? X cubed plus x to the power of 2. So that's 1 to the power of 3 plus 1 to the power of 2. 1 plus 1 is equal to 2. So we have one new boundary, and we do that for the second boundary as well. So if x equals to 2, right, the upper boundary, in terms of u, it's going to be 2 to the power of 3 plus 2 to the power of 2. 2 to the power of 3 is 8. 2 to the power of 2 is 4. 8 plus 4 is 12. So the new boundary is going to be 12. Now with all these things in mind, we could write the new integral. So we're going to have the following. We will have the definite integral from 2 to 12, and in the integral we're left with the expression of du divided by 2 to the power of u squared. 2 times u to the power 2. Anyway, let me just write it because I'm talking too much. 2u to the power of 2. Yes. Right? Now, what can we do here? We can take the constant out, because this is 1 over 2. This is 1 over 2. We could take it out of the integral. So what do we have now? 1 over 2 multiplied with the definite integral with the boundaries between 2 and 12. 2 and 12. And here we're left with du divided by u squared. Well, we have 1 over u squared, right? That's the same as 1 over u squared, which we could rewrite as u to the power minus 2, and then we keep the du. So times du. Why did we do that? Well, because we can use the power rule of integration. So we're going to have 1 over 2 multiplied with the boundaries from 2 to 12. So let's keep the boundaries over here, 2 to 12. And when we integrate u to the power of minus 2, we're left with u to the power of minus 2 plus 1, that's just minus 1, divided by minus 2 plus 1, which is also minus 1. What else can we do now? Well, we can take one more constant outside of this whole thing, right? Because we have here minus 1, we could take it out. When we multiply 1 over 2 with minus 1, well, we get as a result minus 1 over 2. So we have minus 1 over 2 multiplied with this expression between 2 to 12 of u to the power of minus 1. And by the way, let's just write u to the power of minus 1 as 1 over u, because it's the same. Now, with that said, we can substitute the boundaries into this expression. So what do we have as a result? Let's see. We will have minus 1 over 2 times, let me just change colors for that. We have 1 over 12. We put this one over here. So we have 1 over 12 minus 1 over 2. So minus 1 over 2. Now what we can do is that we can make the common factor over there, the common denominator. This is 12, this is 2. 2 times 6 is going to be 12. So meaning we'll have now minus 1 over 2 multiplied with, and in brackets we're left with 1 minus 6 divided by 12. What's 1 minus 6? That's minus 5, meaning that we're going to have minus 1 over 2 multiplied with minus 5 divided by 12. If we work the math over here, what do we get as a result? Well, minus 1 times minus 5 is just 5, and 2 times 12 is 24, and that's it. Hope this makes sense, and we are done.